I have been keeping all of your unit tests, all the corrections that you've made, the reflections that you've done in one folder. Because if I had let you hold on to these, let's see, what could go wrong?
It would have been in the backpack.
It would have been in the backpack somewhere. It would have been lost. It would be in that, the big green monster.
Hey. Someone would have taken it with my
Big green monster. Or these would have made it out onto the streets into the hands of AB students. What I wanted to do, and what I normally do, is I hold on to these until right before the semester exam when you are probably in need of more practice and more all of the things, more stuff. So I'm going to give you your folder now if you want it, under the condition that number 1, no AB student anywhere gets to see it. They've already completed units 1, 2, 3, and 4, so I'm not worried about that. But unit 5, you've just taken, and we start in January with the AB kiddos. And you cannot show them the test. I want to make sure this part comes through loud and clear. If you show it to them, I will consider this an honor code violation. Okay? And I'm saying it not because I think you're going to do it, just because I want to make it super clear. This is cheating. This is the definition of cheating. All right, Ale, I'm going to need these back on Monday. Celeste, Aaron, you're welcome. Giselle, Lewis is over there. Steven, Carmen, Myra, David. All right, and then friends over here. Woo. Andrew, Lewis, Steven, Carmen. Okay, so you guys can put those away. You don't need them right now. What you do need right now is last night's homework. I'm going to need to collect from you all your those folders on Monday. Okay?
So like before the test or?
Monday at the beginning is fine.
Okay.
Okay? Alright, so last night's homework, let's take it out. We're going to go through and I'm just going to quickly tell you what the right answer is. You're going to indicate, is it right or is it wrong? Is it okay if I borrow this for a second? Okay. After we've gone over the answers, you're going to summarize your results on the little tally sheet. This is the thing I intended to have ready for you guys yesterday morning and I didn't have ready. My apologies. And here's the thought behind this. I think it's going to be really helpful for you to be able to look at the results and say, wow, there were 2 questions from Unit 1 and I got both of them right. That's a really good sign. Or gosh, out of the 3 questions that came from Unit 2, I only got 1 right. That's a bad sign. That's a sign that you need to be doing some specific studying in Unit 2 things. Okay? The only thing I'm going to ask you guys to turn into me after we've gone over the answers is this sheet. That way there I can get the data, I can score it, I'll give it back to you tomorrow. The last thing I want to say is that I'm closing my grade book tomorrow. If you have any corrections that you want to get done, tomorrow is the last time to turn it in. Tomorrow when I leave here. Okay? So any corrections due tomorrow. If there's a late assignment that you're just going to bring in with a donut attached to it, tomorrow is the last day, Aaron. And Shipley's, they better be hot and piping. Hot and piping, I'm not sure. Oh, those kolaches. You could be cold and covered in goo, I'd still eat it. Alright. Alright, so last night's homework. What was the first one?
9.
9, C. Next one?
11.
A. Next one?
12. Oh, you're 12.
12.
Oh,
12, J.
And then
Somebody can get that? 13 is D. How's everybody doing? Okay.
15.
15, B. 16, J. 17, A. And then you said 18 and 19 as well?
Yes.
18 is G. 19 is D. And there's probably a couple
22.
of 22, J. And
23.
23 and 26, those are the last ones?
Correct.
23A. 26J. Okay, I'm sure you have figured out after 2 nights of these, I am not picking easy questions.
Yeah.
You're not going to grow and get ready by doing easy questions. You'll feel good now and then want to die on Monday. I'd rather you have slow deaths every night so that when the big one comes, it doesn't feel quite so bad. Alright, so do your little tally. Four, 7, 11.
No, I just don't.
Are you picking up the free response?
Yes, so if you could put your tally sheet and the free response in the middle of the table, I'll take care of that.
From yesterday?
5, 6, and 7?
Yeah.
5 with D, 6 with H, 7 with C.
I'm in.
And we've got time maybe to talk about 1 or 2 questions, so let's choose wisely here.
Can you talk about the other from yesterday?
Or the ones from yesterday, that's fine.
It seems that the rest of the calculation error.
Okay, thank you for publicly calling her out. Lewis, what's your request?
3,
All 3?
number 3.
Number 3. Okay, so number 3. Now actually before we do that, I'm going to set the timer. At 9:05 we're going to stop. For those of you that don't have any questions, here's tonight's homework. So tonight's homework in that same packet. This is the last round. 21, 25, 27, 29.
Kiddos, it's on the back.
You can do it that way too.
Oh my god,
30, 30, but you're not going to have that sheet, Smarty Pants. I'm picking it up. 30, 32, 33, 39 to 47. This feels like a long stretch. Most of these are calculator active. Okay? I want to make sure you still get some good practice with calculator skills. 21, 25, 27, 29, 30, 32, 30, 33, 39 to 47. Yeah. No problem. Okay, so between now and 9:05, I'm going to take questions from anybody who's got them. And if you don't have questions for me, work on the one that's due tomorrow. Lewis, you want to talk about number 3? Alright, let f be the function defined by f of x equals 2x plus e to the x. G of x equals f inverse. Find out for all values of x at the point 0, 1 is on the graph of f. What's the value of g prime of 1? So, Lewis, what I hope happens is that when you see this notation, you know that they're telling you something. What are they telling you?
Then G of X is the inverse of the way.
Okay, we've got inverses. Now, we haven't really done that much with inverses in a really long time, and even when we were there, we didn't do a lot. You just need to know the derivative formula. And the derivative formula says that g prime is 1 over f prime of g of x. This is just one, you just have to have it memorized. It's not going to show up a lot, it's going to show up a lot. Just like derivative of something like arc sine, derivative of arc tan. Not big, but enough. So in order to make this work, I need to know f prime, and I need to know g of x. They told me what f of x is, but they didn't tell me what g of x is. We know that f of x is 2x plus e to the x, and that the point 0, 1 is on the graph of f. So how are we going to find g prime of 1?
Plug in 1 for G of.
Okay, so that means we've got 1 over f prime of g of 0. How are you going to figure out g of 0? Wait, is it g of 0? No, g of 1, sorry. How are we going to figure out g of 1? I kind of gave it away there.
0.
Yeah.
Why is g of 1 0?
It's from the
Aaron, why is g of 1 going to have to be 0?
Because if it's the inverse of f of, yes, f, then you just switch the coordinates.
Right, this guy here is, because it's on the graph of f, what you're saying is that if I plug 0 into f, I get 1. But if these guys are inverses, then what that means is if I take that 1 and plug it into G, I have to get 0. Right? That's that switching relationship. So now I've got 1 over f prime of 0. Do you know how we're going to find f prime of 0?
I plug it in.
Plug in where?
The f of x equals to like.
Careful, not to f.
Or find the derivative.
You've got to first find the derivative of f, then plug in 0. Are you okay if we stop there? Okay, other questions from other friends? We've got 6 minutes. 22.
Oh, I was like, that's not one of
A
them.
request from the lady with 2 copies of the assignment. Oh, 22, such a good question.
Almost 3.
Oh my god, I love 22. I wish I had written number 22. You ever like fall in love, and you remember like that first moment where you laid eyes on the person and you're like, changed my life forever. I feel that way about Kalachi. No. No, I feel that way about this question.
Why the eating
Truly, this question, first time I saw it on the AP exam, I was like, oh my god, somebody wicked smart wrote this question, and I need to evolve my thinking about how I assess kids. Love, everything you know is right here. So I need to figure out how to compare f of 1, f prime of 1, and f double prime of 1. Right, that's the goal here. I've got to be able to make comparisons about f of 1, f prime of 1, and f double prime of 1. Is there anything that anybody knows about any of these values? Based on the graph, anything you can say with confidence. F of 1 is 0. Why is that true, Myra? You're 100% right. Tell me why.
Because it says that the graph, this is the function f. This is graph f.
And what's happening on the graph of f at 1? It's at 0, you have a root, but you know what? There's more than you can say about what's happening on the graph. Polymon, what else do you know?
Concave down.
The graph is concave down. How does that help you figure out one of these values?
It'll tell you that f prime is decreasing.
If f is concave down, I love that. Okay, f is concave down means f prime decreasing. That's good, but not as good as the next thing I hope somebody's going to tell me.
It means f prime is less than 0.
This means that f double prime has to be some negative number. Negative what? I don't know. But I know negative. Lewis, what do you know?
Wouldn't f of 1 be greater than 0 because it's increasing? Because f of...
Wait, I heard you say f of 1 is greater than 0. And why is that true?
Because f of 1 is increasing.
Okay, f is increasing, which means that f prime of 1 has to be positive. Plus.
Thank you.
Myra, are you okay from here?
Yeah,
Okay.
So that's good.
The graph of f is increasing at 1. If f is increasing, what do you know? F prime has to be positive. You got it?
Prime is positive.
Now that you've got the 3 pieces together, is this okay? From a conceptual standpoint, I think this is a brilliant question. You didn't have to do any computations, you didn't need to memorize any formulas, it's just like, do you know stuff? Love this question. For whatever that's worth, let me just say as a test writer, God, I love that. Would love to see it more often. Okay, 2 minutes left. Kids at East End are like, this question's going to be on the exam. I know it.
Oh, snap. This question.
And I feel bad. There might be students at North Central who are like, please pick question number, fill in the blank. And I'm not getting the psychic message. We've got time for one more.
Wouldn't it be time travel?
That too. Let's focus. Myra gets 2 packets, so she thinks she gets 2 votes. Myra's voting for number 14. Does anybody else? No?
No,
Giselle, do you have any other questions? No? Okay, back to the pushy girl. Okay, 23. Alright, 23. F prime is equal to all that stuff. Then F has which of the following relative extrema? Andrew, how do you classify extremum? What do you do?
Sorry. Well, what I did was just look at when the graph equals 0.
Okay, when the graph, now I want to be careful because what you have is the derivative. Okay, so if I want to classify the relative extrema, when I say relative extrema, what we really mean is relative max, relative min.
0.
How on earth do I ever figure out if I have a relative max or relative min?
Looking at the candidate.
I'm going to look at
Candidate.
that you're thinking absolute max and absolute min. Relative max and relative min, I'm just looking for where the derivative changes sign. How am I going to figure out where the derivative changes sign? I need to find the zeros. I need to do my number line test and stuff. So here's f prime. I need my roots. My roots are at 2, 3, and 4. I hope that's okay.
Are you okay?
Yeah, fine. Pick a number to the left of 2. I'm gonna like something like 0. Plug it in. I get a negative. I get negative squared. I get negative cubed. So negative, positive, negative. This should be positives there between 2 and 3. Like 2.5 maybe. Positive. Negative squared. Positive. In fact, this guy only ever gives me a positive. Right? 2.5 minus 4 cubit. Is that negative? Negative here, positive. No, wait. It was positive here, right?
Yeah.
Positive, positive, negative. We've got negative. If I go over here, that's positive. That's positive. I think that's negative. And then we're positive. So based on the number line, the conclusion I can draw about x equals 2. This is a relative max at 3.
A double root.
The graph has a double root. There's something special that happens at 3. We haven't used the word in a long time. The derivative is equal to 0. It's not a cuss point. Derivative is equal to 0. The sign's negative before, negative after. Think about the graph. The graph decreases, flattens out, decreases some more. We call that
Point of
Saddle.
inflection.
not point of inflection,
Saddle.
saddle point.
Sorry. That's not.
And saddle points are good, but it's not a relative extreme. It's not relative max or relative min. And then this last guy over here, relative min. Okay, all the friends are good? All right, here's what I want you to do. If you could leave that stuff in the middle of the table, we'll continue talking about homework tomorrow. I wanted to give you guys a study opportunity here. So I want you to find somebody else in the room, somebody you are not currently sitting with. You are going to have a stand-up conversation. You have 3 minutes to fill in as much of this table as you can without using your notes.
I have 5, 6, and 7.
Yeah.
I got them. I did mark them.
That's why I said calculation here.
Do you want me to check them?
Yes, please. 5, 6, and 7. I'm sorry. 5, 6, and 7. 5, 6, and 7 are the ones that Celeste can't bother to write down.
Sorry.
3 minutes. Fill in this table as much as you can. This is a standing up conversation.
Wait, what? Look, every vector.
Carmen, you can do it. You can have a standing up conversation.
Alright.
The vector is increasing in every time.
For those of you that are really physical, if you need to walk around to make it stickier, feel free.
Relative max.
If you got a camera, bro. What?
Relative maximum.
Man, get it too fast. That's one.
There's not exist. Or is that undefined or something? The same thing.
It's not a flip.
Or is it not the tangent? X equals what?
I put x equals a point.
Oh, yeah.
Or it's not a tangent.
I'm pretty sure when you do this, when you get a relative maximum, what's happening in the And then like prime, it's going from positive to negative. B.
Isn't that it's like horizontal? So it's more with a graph is. Is that a limit? I forgot
1
if
minute.
it's a limit or if it doesn't exist. I think it's a limit.
Plus point is
There's no horizontal thing.
I know it's something
where
limit.
the graph never reaches. Isn't that like a limit?
Is that, or is that horizontal? Is it?
Because it's a horizontal tangent line, so it's like where it never touches. With a function, like the whole function never touches.
That's an asymptote.
No, what's it?
Remember, you don't touch that asymptote?
Yeah, I know that.
Don't
I know-
touch that
I know
asymptote.
that, but like,
Bad things happen.
but a tangent line is similar to that.
Yeah,
Now, where there's the point is undefined.
I know there's something that equals 0. One of these equals.
I know. I think it's tangent line. I think it's tangent line.
Is that one tangent line?
It can't be an asymptote. Asymptotes don't equal 0. That's where it doesn't exist. Like it's undefined.
So then, what?
Asymptotes is where it's undefined.
Yeah.
But when
So
you-
then,
what
it's
tangent
a limit. It's like it's a limit that does not exist.
Wow, thanks.
for asymptotes?
All right,
I feel like I'm
friends,
saying
let's do
dumb
it.
stuff on camera.
Focusing on the top 3 boxes. I'll take anything from anybody. You can keep standing up if you want to, or sit down. It's fine by me. But let's get some hands on this. Something that you know for sure. I like.
If F of x increasing, f prime of x is positive.
If f is increasing, f prime is positive. Nice. Celeste, something else.
If f of x has a relative max,
Relative max.
f prime of x is changing from positive to negative.
Changing positive to negative. Love it. Carmen.
Oh, that would have been
Good track.
If f of x has a close point, then f prime of x does not exist at x equals c.
At x equals c, yes. Steven. Sorry.
When f of x has a relative minimum, then f prime of x changes from negative to positive.
Negative to positive. You guys are all staying in that top row. I understand. It's safe there. Aaron.
When f of x is decreasing, then f prime of x is less than 0.
Good. Okay. Those are the ones that I would expect you guys would all know without any studying whatsoever. Now let's up the ante. Myra.
If f of x has a horizontal tangent line, then f prime of x has to 0.
If f has a horizontal tangent line, f prime must be equal. You caught that like a boss. He was like. All right. Next. Carmen.
If f of x has a vertical tangent line, then f prime of x has a vertical asymptote at x then.
If f has a vertical tangent line, think about the tangent line at that point. The slope of the tangent line is, it does not exist. Right, what we're really looking for is exactly what you said. You're going to have a vertical asymptote here. You could also say does not exist, and that would be true. But the important thing, nice, with a vertical tangent line, the slope's approaching infinity, which is why you're going to have an asymptote. Okay, how about some of the other ones?
Does not exist at saddle.
Not true. We were just having a conversation about a saddle point. Imagine the graph, decreasing, flattening out, decreasing. To be a saddle point, 2 things have to happen. What has to happen?
F prime of x has to equal 0.
First of all, the derivative has to be equal to 0, and secondly,
If the derivative does not change sign.
there's no change in sign. Good. Okay, horizontal asymptote. I know you guys all know what a horizontal asymptote is. It's impossible for you to have gotten here without knowing it. But what happens, think about a graph with a horizontal asymptote, like the graph of e to the x, or the graph of e to the negative x. What happens to the derivative? Uh-oh. What happens to the derivative? Think about the graph of like e to the negative x, which decreases, 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 starts to flatten out.
Approaches 0.
That's as much of a hint as you're going to get out of it.
Approaches 0.
We're approaching 0. Okay.
Oh, snap.
Yeah.
Missed again.
Sorry. Okay, and then lastly, if your graph has a vertical asymptote, Lewis, what do you know?
Vertical asymptote.
You have a vertical asymptote forever. All your derivatives. Sorry about that, Carmen.
Thanks.
All right, when we say critical point, that means f prime equals 0 or does not exist. We consider both. Monotone increasing, strictly increasing, we do not use these words very often. They're rather old school. But what does monotone increasing and strictly increasing tell you?
Always increasing.
Always increasing. So this is a like strictly positive situation. It never flattens out. It's always increasing, always decreasing. All right. Really interested in these last three. This is called out. If f is concave up, f prime is... If f is concave up, imagine concave up, concave up. F prime is increasing. F double prime is positive. Now, here's the important piece. Graph is concave up. Where do those tangent lines live?
Below.
Uh-oh. Think about any graph that's concave up.
I know.
Concave up, I still sketch it, and I'm like, oh, tangent lines, they're all below. And so if they're below, then you know about your approximation. Underestimate. Now, secant lines, the reason I want you to be thinking about secant lines is there's something that we did that involves secant lines. Secant lines connect the curve in two places, right? I'm not drawing it well. Riemann sums?
Yep.
If you have a graph that is concave up, what kind of approximation am I poorly sketching here?
Oh.
What kind?
Oh.
Left endpoint method, right endpoint method, midpoint method.
Trapezoid.
If I'm using secant lines, this is a very poorly drawn trapezoid. But the secant lines are going to be above, which means you're going to get an overestimate. So of course, concave down, we've got this one. Decreasing, negative. They're going to be above. You're going to get an overestimate. Secant lines are below. And we're going to get an underestimate. Nothing too exciting happening there. Okay, lastly, if f has a point of inflection, right, well, you got to be careful. If f has the point of inflection, f prime changes from increasing to decreasing, or the changes from decreasing to increasing, right, Polymon? You were having thoughts about double prime. So this would be a change from positive to negative or negative to positive. Okay. Everybody feeling mostly okay? Alright, so here's what I want to do. I want you to get an opportunity to put this into practice. So in the practice questions packet, what I want you to do is find question number, where are you? 49. Okay. You're going to go 10 minutes completely on your own. No help from anybody. I want you to do this question as though it is the semester exam. We'll talk in 10.
49.
49?
Yeah.
For the folks watching the video, you might want to just hit pause, work for a little bit, and then fast forward the video by about 10 minutes.
2.5 minutes left.
I can hear you. Good. Two minutes left. Semester exam on Monday. Circus boy crazy is coming.
He didn't even ask me questions, he was just talking.
I know. That's when he starts talking back to himself. So I answer all the questions. Okay. So that's 10 minutes. Now here's the thing before anybody freaks out and you're like, I can't go to college now. Number one, free response exam, free response part of the exam on Monday, you have 45 minutes for 3 questions. You don't need to be working at a pace of 10 minutes per question, you need to be working at a pace of 15 minutes per question. The reason I wanted to go over this is I would think, and I say this with all the love in my heart, I think this is an easy question. I think this is a straightforward, this is exactly all the skills we've been working on. If you didn't just feel that way, I don't need you to feel bad about this, I need you to do something about this. This would be a sign to me that, like, I need to do some extra studying. Alright, so, are you guys okay if I just show you, like, the rubric?
See.
Okay, so here comes the rubric. Okay, part A, right? You need to write the equation of a tangent line. Anytime we've written the equation of a tangent line, you need 2 things. You need a point, you need the slope. They told you f of 2 is equal to 1. F prime of 2 is -1/2. David, where does this -1/2 come from? You went to the graph. It's a graph of f prime. I need to know what's the y value at 2. The y value is -1/2. Put it together. L of x doesn't have to be L of x. But what it can't be is f of x. It can't be f prime of x. It has to be something, not that. L of x is -1/2 parentheses x minus 2 plus 1, 1 point. You only are going to get 1 point for this. Alright, part B. Now you need to do an estimate. The estimate for f at 2.7 is going to be approximately, the squiggles are nice, it's approximately what you get when you plug 2.7 into your tangent line. -1/2 parentheses 2.7 minus 2 plus 1, you get a point for that.
Wait,
Please tell me no one simplified.
you don't have that.
We don't simplify numbers. All that you can do by simplifying here, Aaron, is throw away a point. That's all you can do. Now, if you simplified it, that's 0.7, that's -0.35, 0.65, so 65 hundredths if I'm speaking like a 6th grade teacher. Number 1, don't waste the time. Number 2, don't jeopardize the point.
Okay, so just the setup of all.
Right. All I need, and this is true for every single question, when you hit numbers, stop. For example, what's sine of pi over 3? Who cares?
Oh,
It's a number. No, it's not because it's an approximation. Sine of pi over 3 is a number. Some of you are like, is it a half? Is it square root of 3 over 2? Wasting brain space. Sine of pi over 3, move on.
Oh, so as long as it's
If everything is a number, stop. Okay? Alright, now here comes the justification. The justification is always tricky. This is probably the hardest part of the whole thing. You have to tell me what's happening on a very specific interval. From the point of tangency, which is x equals 2, to the point that you're approximating, what do we know about the concavity of f? And how do you know about the concavity of f? From 2 to 2.7, if I looked at the graph, f prime is decreasing, which means if f prime is decreasing, f is concave down. And where are those tangent lines? They're going to be above, so it's an overestimate. The first point is easy to get, the second point, way hard to get. You have to tell me the interval, you have to tell me the behavior of the graph that you see, and you have to tell me what that tells you about f. Then you get to the tangent line. It's just a lot to write. It's really specific, lots of ways to lose that point. Alright, part C asks for horizontal tangent lines. Well, tell me about horizontal tangent lines. If f is a horizontal tangent line, f prime is going to be equal to 0. That happens at -1 and 1. You have to make the connection. You always have to make the connection to the graph that you see. If you don't tell me f prime is equal to 0 and you just list x equals -1 and x equals 1, so sad, no point earned. Now you have to make a justification. Well, what happens at -1? At -1, f prime makes a change from positive to negative, relative max. At x equals 1, what happens? F prime doesn't actually change sign. So what do we know?
Saddle point.
Saddle point, but saddle point doesn't answer the question.
Neither.
It is neither. They're asking you relative max, relative min, which one is it? It's neither. Saddle point is nice, but doesn't answer the question. How many of you guys are up to 5 points or more? Okay, good. All right. Part D, now we're looking for points of inflection. F has a point of inflection. Well, if I'm looking at the graph of F prime changes from increasing to decreasing. That happens at -2 and 1, point for that. Or F prime changes from decreasing to increasing at x equals 0, point for that. Okay, and then lastly, G prime, or G was f of x, right? So G prime of x, of course, we're going to be thinking chain rule. F prime of f of x times f prime of x. That derivative gets you a point. To get G prime of 2, find f prime of f of 2 times f prime of 2. Find the values, you're going to get 0 as your final answer. This whole problem would be worth 1, 3, 6, 8, 10 points. Did anybody get all 10 points? 9 out of 10. 8 out of 10. Okay, I can feel good about that. I can feel good about 7 out of 10 as well. Okay, but seriously, like, not to be mean, this is a kind question. This is straight up all the things that you know to do. Now it's time for the push. We've got about 4 minutes left. You're not going to get too terribly far into this question. For anybody who is looking for one last opportunity for a homework assignment grade to go away, for those of you that listen a little bit more there, question number 53 was a blood bath when this showed up on the second trimester exam a couple of years ago. If I didn't say it yet, tomorrow after class is over, I'm going to send you my solutions to all the multiple choice and all the free response so you guys have access to this. Kids at East End and North Central will be getting the solutions as well. This is the best study material I could hope to provide for you guys. Okay. All right, you get the last bit of time to see what you can do at question 53.
Question 53, if we turn it in, will only help us, right?
Question 53 can only help you if you legitimately do all the parts. 53. Oh, just like I did with 52. It can only help you right now. Mr. Right. This is beginning class. You're going over
And I want to do like 10 minutes review. I'm not sure. I'll be back like that.
Wait, I know you completed it.
And probably require a lot of guidance there.
Yeah.
If you could reading that.
Yeah.
And then these two multiple choice. 10 minutes or so.
Okay. And we want that, like they can work together during that time.
Yeah. I think so. I think they'll need to. This one is okay. This one. And then 25. I think that'd be better. But, okay.
So we'll do that?
Yeah.
Because I also think going over the table.
Yeah.
Okay. Small thing. Don't call it.
Scarlet. I'll call it.
If this is the graph of V, there's only one thing you can't call it.
Is that it?
Yeah, oh, so it gets technically, right, you can call it A of T, you can call it V.
Okay.
Yeah. Okay, just a quick show of hands. How many of you guys are planning on staying for the study thing tomorrow here? 1, 2, 3, 4, no? Looks like 5. Okay. Tomorrow, make sure you have your calculator. We have to put them in press to test mode. BC students watching at home on video, bring your calculator. We're putting your calculator in press to test mode.
Alright, can you guys go into the cram session tonight? I'm gonna show up at like 4:30. I want to do the